All right, we're going to present our hackathon entry. Team Ornn. We've got some of our team joining us from our Broadhead office, Broadhead, Wisconsin, and then also in Houston, Texas. We are going to be presenting our entry for predicting markets through machine learning. So to introduce the team, start off with our Houston co-worker, Scott Coldwell, has joined us there. Topmost picture. Myself, I'm the bottommost picture there. Nathaniel Francis, the nice smile on the right. And then Kurt Grath on the left side there with his hackathon hoodie. So we are Team Ornn. So let's talk about Project Ornn and what problem it solves, how it's of value for Ritchie Brothers. Marketing for the future. We don't want to be about basing our marketing on a long time ago in a galaxy far, far away kind of data. We want to be smart about how we spend our marketing dollars, how we match up customers with assets. And so our project and the solution really looks forward rather than backwards. Instead of looking at raw historical data, we actually take the data and draw correlations from that data to make those correlations available for prediction of what will happen and what customers are interested in, what actions they will take going forward. So Project Ornn delivers predictive analytics. Predictive analytics use, as I mentioned, the data. You couple those with statistical algorithms and the most important machine learning techniques to identify the likelihood of future outcomes, that specifically with our customers and the choices that they make in purchasing of assets. And that's all based on the historic data that we pull in. Resources we utilize for this project, we pull data from Customer Data Hub. All three of these resources I'm going to mention here include IP web data and also RBA data. Second part is asset data. That was part of the hackathon sample. And so we pull that in and use that to train the system. And then last, the hit data that was made available, that is also pulled in. And once again, all of these include a cross-channel data set, both IP web and RBA. Technology used for this project, we actually used Erlang for the machine learning aspect, ColdBox, the Cold Fusion framework, the React project, and MS SQL. We've got Node.js in play. We're going to hear a little bit more about that in a bit here. Couchbase. We've got Docker in play and Kubernetes as well. And then the most important, the Force, as you can see there in the middle. Technology is not used, no Java. So let's get on with the demo.
Welcome. I'm going to give you a brief demo of Project Ornn. Project Ornn is designed for marketers to sell assets to the best possible customer. So what it does is you create an asset that you're wanting to sell to the customer. That then will call a machine learning algorithm to get you a profile of the best customer to sell this asset to. So let's go ahead and do that now. We'll call our machine learning algorithm. We'll bring up our inspector just so you can see this is actual working demo. We'll show the machine learning later. So this machine learning said we should look for someone with a bid limit of around this size, company size about this, who've been a customer for 29 to 43 months. So that's great. I think I'm happy with that. So let's search and call the Customer Data Hub and get customers that actually meet those criteria. So we can see we return a set of data so that we can immediately start marketing to these customers. We can take a look though and see that most of these customers are RBA. So when we list this particular asset, we will want to do it on an RBA auction site, it kind of looks like. There are a few IP customers, so we don't want to ignore them, and there's several customers in both. So let's look at selling a different asset now. So I'll maybe change the price that we're trying to sell this at, and we'll change what we're selling, and we'll call the create customer profile again, which will get us back a slightly different customer. And maybe we're not happy with that. We want to sell to people with higher bid limits for this particular one. So let's search for those customers. And again, you can see we're making actual calls to the customer data hub. And as you can see, it returns a different set of customers based on our match. And these are a little bit skewed higher towards IP web. So maybe this particular asset we want to sell more on IP web. Also, Ornn is mobile friendly. So if you want to sit with a seller and figure out the best customer to sell to, and they can kind of help you define this, you can do it, of course, all from your phone as well. So that's it for our demo of the UI of Ornn.
We're going to hear about the API now, and Nathaniel Francis will be presenting.
The Node.js API, constructed with Express, intermediates processes between the React user interface, the R-based predictive analytics, and the customer data hub. It marshals API interactions, normalizes data structures, and interfaces with each part of Ornn, essentially tying all of it together. The two primary workflows that run through Ornn are the asset to profile workflow and then the profile to customers. In the asset to profile workflow, Node.js receives the asset data request and directs it to the predictive analytics. It then returns the generated profile from predictive analytics back to React for manual adjustment or assessment by the user. Node.js picks up again when the user submits the profile data for customer query. It takes the request and queries the customer data hub for customer records that match the parameters of the profile, returning that data to the React UI. Tying React, predictive analytics, and CDH all together is what Node.js does for Ornn. It keeps everything working together.
All right, and now Kurt Gratz for the machine learning predictive analytics.
Welcome, everyone. I thought I'd take a quick second and show you how we do the machine learning in Project Ornn to do our predictive analysis of assets to predict a customer profile to sell that asset to. If we take a look at our R program, we have a data set that we're training our predictions off of. We can take a quick look at that data set. It is a combination of asset data, hits, and customer data across both IP, web, and RBA customers, also combining data from the customer data hub to fill in all of our data. So that is how we build our data. That's put together by an application that we wrote to do our training aggregation to build that training set, and that training set then feeds our predictions. So then we took a look at our training set and we tried to tease out some various correlations. So we did some plotting, etc. And I am by no means a data scientist, so this was all just kind of me poking around and finding some stuff that would work, and we can obviously tweak this model as we go forward. But this is good for a proof of concept. So what I did is a number of linear regressions were used to predict the customer profile, as well as one machine learning rules engine, the Apori, I think that's how you say it. Again, I'm not a data scientist, to predict a location based on the asset of where a customer, and then we return a set of those back for the front end to use to predict or to get a set of customers that would be interested in this particular asset. So again, we then take our data and just do further linear regressions on it by filtering it in different ways to come up with the best possible prediction based on the asset that's sent in, the price, the category, manufacturer, location, etc. of the asset. We will give you a customer profile of what a customer might look like that would be interested in that asset based on our historical data. So that's the predictions that we're doing. So if we take a quick look at one of these, we'll look at an asset with an asking price of $1,000 in the drilling category. We didn't supply a manufacturer. Looks like it's located in Orlando, Florida. And based on our data, we should look for people with a bid limit of around 50,000, company size of about 500 employees that have been customers for quite a while, and our primary locations looks like are Texas and Illinois that we should look for customers in. So that's a little bit of how the machine learning was done for Project Ornn. Thanks.
All right, questions and answer time. On behalf of Project Ornn, I'd like to thank you for your time today.